In this section, we want to learn about the properties of integer exponent. When I write like this, we read it as a to the nth power. Sometimes we read it a to the power of n or a raised to the nth power. But the most common expression will be a to the nth power. This a is called base number, and this small number written top right corner is called exponent. What does that mean? The base number is multiplied n times. Other basic but important property you have to keep in mind will be when we write the number a, that can be expressed as a fraction, a over 1. So we have number 3, then 3 can be written as 3 over 1. When we use this basic property, we realize that the number a multiplied by 1 over b can be considered as a over 1 times 1 over b. So when we have a fraction, when we have two fractions, we multiply the numerator together and denominator together, so we can write it as a over b. So a times 1 over b can be written as a over b, and if you see a over b, sometimes it is more convenient to write a times 1 over b. Those are the basic properties you already know. Let me state the properties of exponents. We have b to the nth power times b to the nth power. Then that can be combined and written as b to the nth, m plus nth power. Why is that? For example, if we have 3 squared times 3 cubed, then that can be written as 3 times 3 times 3 times 3 times 3. So total number of multiplication is 3 to the 5th power. If we have abstract base, then u to the 4th power times u to the 5th power can be written as u to the 4 plus 5 power. Then that is u to the 9th power. The next important property is b to the m power or over b to the nth power. is b to the m minus nth power. For example, if we have y to the 7th power over y squared, then that is y to the 7 minus 2. So that is y to the 5th power. If you think about number, then it may be more intuitive. If we have 5 cubed over 5 squared, then that is 5 times 5 times 5 over 5 times 5. And the same number in the numerator and denominator will cancel each other. Then that is 5. Indeed, 5 is 5 to the first power, so that is 5. What does it mean? We subtract 2 from 3 in the exponent. We have b to the nth power, parenthesis, nth power, then that is b to the m times nth power. Let's say we have v to the 7th power, parenthesis, cubed, then that is v to the 7 times 3 power, so that is v to the 21 power. If you want to think about that with number, then that'll be 5 squared cubed. What does that mean? 5 squared is multiplied 3 times. So each one has 5 times 5 and 5 times 5 and 5 times 5. So altogether, that becomes 5 to the 6th power, 6 times multiplied. Indeed, that comes from 2 times 3. The next formula is a b parenthesis to the m equals a to the mth power, b to the nth power. So the power is distributed to the first factor and second factor in the multiplication. For example, if we have 3 times v to the 4th power, then that's 3 to the 4th power, v to the 4th power. In Alex will not accept this pattern of the answer because you can simplify further. What is 3 to the 4th power? That's 3 times 3 times 3 times 3. So this is 9, this is 9. So 9 times 9 is 81. So 81 times v to the fourth power. You can use non-graphing calculator for the calculation about 3 to the fourth power. However, I expect you to calculate this type of simple multiplication without using calculator. The next one is a over b to the n power. Then that is a to the nth power over b to the nth power. Again, we distribute this exponent to the numerator and the denominator. Let's do some example. The first one is a over b cubed. So that is a cubed over b cubed. So we put the power to the numerator and the denominator. The next one is a little bit more complex. The exponents must be distributed to all the component multiplied. So we distribute to the numerator and each factor in the denominator. So it becomes u to the fourth power squared over 6 squared times w cubed squared. So what does that mean? That is u to the eighth power over 6 times 6 is 36. And then the power must be multiplied together. So w to the sixth power. Next one is 20 times u to the fifth power times v cubed over 35 times u to the fourth power times v cubed. What you have to be careful about is if the base numbers are different, then you cannot combine the power. So we have to sort out the same pattern, numbers together. So I will split the fractions 20 over 35 base number u to the fifth power over u to the fourth power. The next one is v cubed over v cubed. Those two are the same, so we will just cancel out, then it'll become 1. For this part, this one is u to the 5 over 4, 5 minus 4. Then that is u to the 1 power, which is u. And then we want to think about the next one, the number. We want to simplify it. because Alex will not accept the complex answer. So we have to reduce it as much as possible. This one is 4 times 5. This one is 5 times 7. When we have the same factor in the numerator and denominator, then those will cancel each other. So 5 will cancel each other in the first factor. So we have 4 over 7, and then the next factor is u. The next property is b to the 0. If we have a power 0, the default is just 1. Any number to the 0 power is regarded as 1. So if we have minus open parenthesis 7 to the 0 power, then that is negative 1. What is important to notice is if we have parenthesis negative 7 to the 0 power, then this is the base number. So 0th power is applied to this negative 7th base number. So it is 1. But when we write like this, minus 1, indeed this one is minus 1 times 7 to the 0th power. So minus 1 times this part will become 1, so we end up getting negative 1. The second problem is 2 times negative 1 over 3 to the 0 power. Then two numbers are multiplied, so 2 times this part is 1. So 2 times 1, which is 2. The next property is b to the negative n power is 1 over b to the n power, or 1 over b to the n power. All of them are the same. So you should be able to write b to the negative n power to 1 over b to the n power. Or if you see 1 over b to the n power, then you should be able to write that as b to the negative n power. Nine to the negative 2 power. So this is a negative power. So you will think about 1 over, and this part must be in the denominator. So 9 squared. So we can say this one is 81. 1 over 81. Secondly, we have negative 6 to the negative 2 power. Pay attention that there is a parenthesis. So the base number is negative 6. So that is 1 over negative 6 squared. Because of this negative power, we wrote the base number in the denominator. What does that mean? That means negative 6, the base number, is multiplied twice. So it is 1 over 36 because negative negative will make positive. The next one is a to the 5th power times a b cubed over a to the 5th power times b squared times y to the 4th power. Then what I told you was you have to split that into the fractions whose base numbers are the same to proceed with further operation. So in this case, the numerator and denominators are the same. So that is 1. And then the second one is positive power in the numerator minus the exponent in the denominator. So that is, and then let's write down 1 over y to the 4th power. So this one is b to the 1 power times 1 over y to the 4th power. B to the 1 power is b over 1. So that is b over y to the 4th power. So b over y to the 4th power is the final answer.